Eric, thank you so much for joining me today.
Good to be here.
Let's start with the basics. What is symbolic AI and how is it different from other AI approaches?
Yeah, there's really two in this context. There would be symbolic and probabilistic. So if you remember your high school logic, one is induction and another is deduction. So induction is what probabilistic large language models use, LLMs, ChatGPT. Deduction is what symbolic AI uses. So you start with facts and you end with facts. It's fundamentally different. You're not inferring anything, you're deducing things. That's the difference.
How do symbolic AI systems represent knowledge? And also, how does it work in practice when you are building a system to do like a real world use case?
Yeah, it's really gained in popularity or entered the public imagination with IBM's Watson, a generation ago for healthcare. The problem with that was that the technology wasn't such that could scale. It reached the ceiling pretty quickly, and so that was a famous dud of IBM's, as they managed their own decline. And LLMs came in to fill the gap. There are some people that have kind of a religious bent around large language models and probabilistic AIs into its most recent expression with neural nets. But you really need both. You want to learn from the totality of data that's available, but you don't want to bet your life on it, as we all know. These things can confabulate, or in the popular vernacular, hallucinate, which is quite the right term. So you don't want to be doing critical infrastructure with large language models or a ChatGPT, but you can with symbolic AI because you start with facts and you end with facts, and that's what we do with symbolic AI. Is we will enter the facts as an expert would specify them. What is the vibration tolerance for the wing of this aircraft? What is the maximum area surface pressure for this drill? That just is unavailable in the other type of AI. So you deduce, you induce. You really need both in many applications, but in this context, for critical infrastructure, symbolic AI, there's no substitute.
In one of your recent posts, you mentioned that symbolic AI mirrors biological intelligence. Can you expand on that? Can you explain why that's the case?
Oh, sure. What neuroscientists will say is that they study the energy of intelligence. So I'm not inventing anything new in this domain. It's that you can look at plants and insects, all to animals, all the way up to humans, and our ability to reason and our ability to cooperate. And what they find is that there is some fundamental energy differentiation between the way that biological systems work and computer systems work. Chips at their essence are have a degree of determinism to them, but what the conclusion is that there's a magic in, and there's probably a reason for us being embodied in both a brain and a nervous system. So our nervous system is deterministic, but our brain is probabilistic. And the future of a truly sentient being, in the way that Hollywood imagines it, or some of us can maybe get preoccupied in science fiction, is probably that will probably all find its expression in something approximating a biological organism in the way that we have a nervous system and a brain, symbolic and probabilistic AIs.
Right. Maybe it's a good stopping point to talk about Conexus. Obviously, you're the CEO of the company. Can you explain what Conexus does?
Sure. Conexus is a data management platform. What we do is we make more of your data available for large organizations. This starts with systems growing and increasing complexity. So you think of an airplane manufacturer, think of an energy utility, think of a rocket system, where it got started with NASA. Nobody's arguing that the world is getting simpler, right? The world is getting more complex. And so how do you actually manage these devices, not just these little internets, we have in our pocket, but how do you manage the devices such that if you have 5 windmill manufacturers and databases for each. We bring all that data together. Or we have a massive bank. One of our clients wants to use us for, or uses us for risk management, where they collect a lot of data, but they don't use all of that data. In the public imagination, people know Uber. It's one of our clients. They have a global business, databases per city. How do you bring all that together so that you can do better analysis on supply and demand for the benefit of the drivers and the riders? That's what we do for Uber. And so to have Uber describe it, we save them 10 million plus a year with the alacrity with which they can answer ordinary business intelligence questions, because they're able to bring more of their data to bear more quickly versus the classical solution. So that's what Conexus does.
Right. And in your literature on your website and in your posts, you talk about category theory, which is a very interesting connection. You don't see it being mentioned that much in if you look at the average AI literature. So maybe quickly, for listeners who don't know, can you explain like what category theory is and also the relevance to what Conexus is doing?
Yeah, so the reason you don't hear about category theory, which is abstract mathematics that is related to type theory, and maybe you could imagine it being also related to graph theory, is because it's not of the same lineage as machine learning. So there is probability in statistics, machine learning, neural nets, and all that. But the other side of AI is something foundationally different. What this abstract math allows you to do is it allows you to scale those previously unscalable expert systems that we saw back in the 80s. That's what was required. It wasn't compute. It wasn't storage. It certainly wasn't the network. It was discoveries in mathematics that allowed for this transformation to occur, that enables these scalings of expert systems. That's what Conexus AI does. These discoveries in math have happened in the past. So fast Fourier transforms, for example, were required for us to have flying wings be stable. Flying wings like the B-2 bomber, those were invented many, many, many years ago, but it was only with the B-2 bomber that those became stable. And that what happened was that was a fast Fourier transform that was invented and then applied to the design of a B-2 bomber. And otherwise, it would just become too complex to manage. Similarly is quadcopters. Those use probabilistic AI. But quadcopters are fly today versus a generation ago because of technologies applied to them. So we apply the discoveries in category theory. So category theory is related to graph theory, maybe a good way to imagine it. Graph theory, everybody's seen before. You could look at visualization of a graph looking like kind of a spider web of connections. Think of category theory as a graph of nodes and edges, connections with relationships, but in dimensions. So not 2 dimensions, not 3 dimensions, but an arbitrarily large or rich set of dimensions. That's how category theory has expressed itself. So everything can be connected to anything else, but in a formal way, which is what category theory allows.
Earlier, you talked about how a real world system needs both symbolic AI and probabilistic AI, which is neural networks. So, can you talk about what are the not pros and cons, but like what does symbolic AI do well and what does it lack? And also similarly, what does a neural network do well and what does it lack? And obviously, at the end of the day, the hybrid model here, hybrid AI, it ends up working well in the real world. But I think it's good to compare and contrast the two here.
Sure. So what you want to do with an inductive AI, a probabilistic AI, is you want to learn from it. You want to put your data in and then discover. You discover. You see, we've all used these large language models, or I hope many people are even experimenting with them, to explore what the boundaries are, what edge cases are, what failure points there are. We actually have this real world use case right now where we have this very large system for a government that applies large language models to look for security vulnerabilities among all of its systems. And it's something like 1,200 something systems. So imagine applying 1,200 different fine-tuned LLMs across one of the largest pieces of infrastructure in the world. then you want to compose them, the conclusions of 1,200 plus LLMs. What do? You don't use another LLM for that. It would make no sense. How do you trust there are not errors that emerge? And in any case, you have this probabilistic morass that needs to be then encoded into truth to clear out the bugs. Well, then you use a symbolic AI, and so you then have a human in the middle after the composition of the large language model's conclusions that then teaches the symbolic AI. And then you feed the symbolic AI's conclusions back into the large language models and repeat that process. So you learn from the large language model, a human interprets it, and then feeds that truth into a symbolic AI, and then feed that back into the probabilistic AI. That is the virtuous circle. So what we do is we'll do two components of that. We will compose the large language model's findings, and then allow the human to encode that truth in their context into plugging the holes in security in this particular use case.
And we are in the age of LLMs, as you know. Many people are experimenting with them. Some of them are deploying in production. And you have talked about symbolic generative AI. So obviously we've been talking about symbolic AI. Can you explain the term symbolic generative AI, and maybe what is the additional, like the difference between symbolic AI and symbolic generative AI in terms of when it comes to using it in practice?
Sure. Well, you could say a symbolic AI is just the capturing of facts and then the representation of facts. But the generative part is really the same as you would see in generative probabilistic AI. The generative probabilistic AI takes 30,000 word autocomplete, stochastic parrot and all that, right? And it doesn't really necessarily invent new words, but it certainly can invent new sentences to some extent, or at least we think they are, and have no way of difficult to disprove it, in recombining those words in a way that sentences make sense. So you can just imagine on the other side, if you were to take a engineering model from a mechanical engineer, a civil engineer, a petroleum engineer, a geologist, and then you wanted to combine those, a generative symbolic AI could compose them. And so just think of the previous example where we're looking at all of those other large language model conclusions. But in this case, we're taking engineering models. We compose them, and the generative symbolic AI looks to say what contradicts it, another model, and what overlaps. So in the case of one of those examples, what is the maximum area surface pressure for a pipe that is conforming to each one of those other engineering models? It didn't invent facts. It didn't confabulate or hallucinate. And it's not, so it's certainly not making something up, but it is creating something that was a gap before. If you compose a whole bunch of models and then you discover there's gaps, the generative symbolic AI fills in the gaps of the models. And otherwise, that would be a manual process prone to errors that humans just naturally introduce.
Right. And when it comes to integrating symbolic AI with generative AI, it represents marrying rule-based logic with probabilistic generation. So if a company in practice, if they want to implement it in a project, the developers, like, what should they keep in mind? What are the hurdles, challenges? What are some practical guidelines for them to keep in mind when they are architecting one such system?
Besides calling Conexus AI to help integrate their data, besides that, what we do is we are sticklers for specificity or formality. We will program in logic, essentially what we say. The syntax and the language expression is not relevant. What's relevant is the degree of clarity or the lack of ambiguity that is present in the coding. Often when I used to program, I would be lazy, and I would just I would do things that I wasn't supposed to do in hard coding places that I wasn't supposed to hard code, or
Right.
otherwise leaving some sort of technical debt for later. What Conexus AI does is cleans out that technical debt. in critical infrastructure. So as coders, what we need to do is we just need to become a little more disciplined, a little more formal, especially in critical infrastructure. So I don't have a lot to offer for those programmers that are working in generating advertising, for instance. That's just not, it's not our domain. But in areas where we're managing a power plant, we are doing risk management for a bank, we are designing aircraft, we're working on a nation's defense. That part you want to have no errors, right? And that's what we do. But you need to also do it with a degree of speed and a respect for costs that currently isn't available, because we just have this bloat of people that we currently dedicate to solving those problems.
When I was going through your literature, I came across an interesting sentence where you mention something to the effect of the best data models are discovered, they're not designed, right? So you have all this morass of data, and how do you find the best data model? So can you quickly explain that statement, and also just the craft of building a good data model, what goes into it?
Yeah, this is fun. This is funny. This is like uh, the art of data modeling. I feel like has been lost. We don't teach it in school. People really don't know data modeling these days, and that might even come back to the degree to which we teach math or don't teach math, and we need to get back to teaching that math. I think we might just say that we rely a little too much. We'll say what we don't do or what we shouldn't do. We rely a little too much on programming and then testing instead of formally proving. That's what we do. And so our tools, our platform does the proof. It enables the proof. So, in this format, what's helpful is just to say that there is a possibility of having formal proofs on one's code, and that is how you ultimately have a system that has the integrity that you can bet your life on. And so for everybody in the entire tech stack of a digital infrastructure, I can just offer that this is now possible to work alongside of these tools so that you have these formal proofs that enable you to generate these better data models and do wondrous things like we're automating the migration of SAP to Snowflake. Instead of taking 200 people and a couple of years, we're doing it in the proverbial mouse click. That's just something that is now available that previously wasn't available.
When it comes to AI's understanding of language, does symbolic reasoning help our case here? And if so, in what way can it help us?
So what we want to capture are facts. That's what we want to capture. There are facts that exist, not just that there's an infinite number of prime numbers, but there are facts of our expertise for, as they say, maximum area surface pressure, and then there are other dynamics that we will instill, such as the dynamic we've discovered around supply and demand for any particular geography or jurisdiction. If I need to respect the regulatory requirements of one state having a privacy of a license plate versus a driver's license versus another jurisdiction of license plate versus license plate versus driver's licenses, you have to have a symbolic AI that represents those facts, that represents that ground level truth. This regulation requires this respect. You can't do that with probabilistic models. It makes no sense. That's how you have to encode these systems. But there's a time and a place for these probabilistic systems, and that's why I say it's a happy circle from symbolic to probabilistic to humans, and then repeat the circle.
Earlier, you mentioned about how if you want to generate marketing copy, that's not where this would be relevant, and obviously there are constraints of rule-based AI in contexts that require imagination. So in this case, so symbolic generative AI is then the use case then more relevant to power plants and less relevant to marketing copy. Is that a fair statement?
Yeah, it's not relevant to marketing copy. That's what we would say. We will do critical infrastructure, but you could say we're relevant to marketing copy if your marketing copy is served up on SAP, or
Right.
because we will do vendor translations. If
Right.
anybody wants to do vendor translations or application
Right.
translations or query translations, that's what this technology provides. Or fast schema evolution. That's what it provides if your marketing copy is based there. But this is critical infrastructure stuff. So manufacturing, logistics, obviously finance and healthcare and defense and energy, as we talked about. Critical infrastructure wherever it's Uber isn't life and death, at least for us. It's not life and death. Maybe for the executives working there, they consider it that. But for everybody else, it's where there's really life and death consequences of failures where you need to apply symbolic AI.
In the modern AI world, as the models are getting bigger and bigger, one of the key issues to emerge is explainability, meaning people are having a harder and harder time just making it plain and explainable. Now, when we infuse symbolic AI into a system, does that help us address the issue? And if so, how is it enhancing the explainability of AI models?
Yeah, these are fundamentally different. So the reason we can't explain probabilistic models is related to what we say about systems just becoming infinitely complex. When you have the scale that we're now imagining with probabilistic AI, we can't explain how the answer comes about. That's what happens. We have to double check and double check and double check. And we can do a billion-mile test on some of these autonomous cars, but the argument is that that's even not enough to guarantee the safety of some autonomous cars. Right? That's just the nature of that sort of. That's not really confabulation, but those sort of probabilistic models relying on testing. Whereas symbolic AI, it is facts all the way down. If you feed facts into a large language model, you could get out non-facts.
Right.
But if you feed facts into a symbolic AI, you'll get out facts. So it's really fundamentally different. It is completely transparent in how the facts are linked from top to bottom. There is no misunderstanding and no way because you're formally proving. This little device that we all have in our pockets. This thing. A generation ago had a chip not in this thing, but we had little chips that powered these devices that had an error. The Pentium 5 from Intel, and it had this little error. This chip is it's a 6 or 7 orders of magnitude greater. I forget what the number is, but it's really kind of ridiculous, like 5 million semiconductors to 6 billion or something between the Pentium 5 and the chip inside this phone. We can't use just testing for errors to have scaled from the Pentium 5 to the chip inside of this phone. Is the point that I'm making. You have to prove the effectiveness. You have to prove your code, to get back to the earlier question. You have to have a formal verification of the underlying connections of that system, allowing it to scale. And this is the whole argument, is that as NASA discovered when they were building rockets that led to the creation of Conexus AI, and we now apply to a whole bunch of other areas. When the system becomes increasingly complex, you can't just scale probabilities and think you're going to scale your way out of having errors. No, you have to introduce facts, and then there's a place for learning with probabilistic models. It's both symbolic AI and probabilistic AI.
You recently posted about Neuro Symbolic AI, which is combining symbolic reasoning with neural networks. How are Neuro Symbolic AI approaches applied to tasks that require visual understanding? We've been talking about language, and the world is obsessed with language, but humans are visual creatures. So, how do we apply this to visual tasks?
Yeah, that's a good question. I don't know. We haven't done any applications in visual tasks. Just thinking. thinking off the top of our head is the applications we know in autonomous driving, where these images don't really occur to us in the way that the visual images do in large language models, but they really occur to us in the way that they're processed through other sort of systems like the LiDAR and radar on autonomous cars. And that then suggests how these would be interpreted and how these would be processed. So the probabilistic system determines whether or not that image in front is a person on a crosswalk or it's a tumbleweed, or what have you. But the large language, the symbolic AI is the one that would determine the rules for stopping or slowing or requiring driver intervention, or what have you. That would be the interaction with the symbolic AI versus the probabilistic AI. But we haven't done those applications specifically yet. We haven't worked in there. We are busy in our applications in manufacturing and logistics and finance and healthcare and energy and defense and so forth.
Right. Yeah. So, and within this field, what are the research frontiers that are exciting to you, and what challenges are they addressing right now?
Yeah, it is really both exciting and not sexy to be talking about the underlying digital infrastructure, right? I mean, there's a reason that that we're talking like this, and we're not talking on some TV show with 100 million viewers, because it's much more fun to watch some autonomous car go down the road. Or if you've seen autonomous race cars, I mean, oh my gosh, I saw this. This Lamborghini it experimented with autonomy, and they took one of their cars around a racetrack. This is a number of years ago, but that is weird stuff. And that sort of telegenic AI is much more fun. But I will say it's also fun to clean up our digital infrastructure. What's available when we do that is just having more of our data available. So it's so much more interesting for me to then be able to trust that the design of my airplane has more integrity. I mean, this is even in the news given recent events. But how terrific would it be to know that I could? Today we have good systems for designing a wing or designing an engine, but how much better would it be to have the system that is able to compose the wing and the engine and the fuselage together in a provable system with guaranteed integrity? That exists everywhere. There is right now a $6 billion contract that's going up in this one large government that we're working on, and I know of another one that's emerging from another government. We hope to be part of both of these things, but they're really about bringing more data together, and I think that's fantastically interesting, because the benefits of having more of the data that we already collect be available to us, benefits everybody.
I have one final question before we go to the rapid fire round. As you look at the landscape of AI more broadly, what subsectors do you think are poised to grow, either because they're very useful, or either because more customers want it, or in general, just what's set to see a lot of growth here?
People often talk about what jobs are going to be killed, but I'm glad you're bringing up what places are going to grow. I think there actually could be a jobs boom in this broad space, which is that of experts. So, what has been a constraining factor for a growth of experts over the previous generations is all the infrastructure that needed to be put on both sides interpreting the expert. We needed to have these layers of middle managers, essentially, whether they're technical or in human form, coordinating, communicating, encoding expertise. But if I can now have a mechanism of scaling that expertise through these digital systems, what I'm going to need is more civil engineers, more mechanical engineers. I'm going to need more I need more people in healthcare, but with particular expertise to be able to interpret the large language models and then be able to communicate my contextual understanding back into a representation in symbolic AI. We're not experts in healthcare or manufacturing or all these other domains where Conexus AI applies its technology. We have to work with our experts. That is a constraining factor for us. So I think actually that broadly is going to be the job boom of the 2020s.
Amazing. With that, we're at the rapid fire round. I'll ask a series of questions and would love to hear your answers in 15 seconds or less. You ready?
Let's go.
All right. Question number one. What's your favorite book?
Oh, my favorite book. Well, that's an easier one than what's my second favorite book, because my favorite book is the one my wife wrote, ReCulturing. It's on organizational culture and organizational development. How one can operationalize culture in their organization. Melissa Daimler. Yeah, ReCulturing.
Right. Yeah, perfect. All right, next question. What has been an important but overlooked AI trend in the last 12 months?
Gosh, in the last 12 months, that's difficult to say, but I really am going to lean more on my domain of AI. I think symbolic AI is beginning to emerge in awareness, and so I think you'll see more things on symbolic AI and neuro symbolic AI. This isn't necessarily just in the last 12 months, but in the same way that AI hasn't emerged in the last 12 months. I've been doing this for 20 plus years. And so I'll just say neuro symbolic AI and category theory is the cool thing that's emerged.
Right. What's the one thing about symbolic AI that most people don't get?
I think some people think that symbolic AI is old, or they'll say that what changed with symbolic AI is greater storage or compute. And none of that is true. What's changed is a discovery in mathematics, specifically in the domain of category theory. That's what's changed in neurosymbolic AI. It is the future, as represented in neurosymbolic AI. That is what's going to be everywhere over the next decade.
What separates great AI products from the merely good ones?
That's interesting. What from the merely good ones? This is a little longer answer. I asked a couple of the large language models when my brother's birthday would now appear on the Christian holiday of Easter, and two of the large language models I tried failed. Gemini got it right immediately, and then ChatGPT came up with an answer and it said, I got it wrong. I'm going to try again. And then it did it again. I got it wrong. I'm going to try again. And then on the third try, I got it correct. And so I think there's with that little anecdote, what's distinguishing the good from the bad, or the great from the good, is probably some human work, human intervention, human creativity in looking at where these edge cases are that they need to develop. A funny little anecdote, I know this is a lightning round, is the quick checkout from Amazon was discontinued because it was just 1,000 people coding in the background. It wasn't really AI. So that's another little funny way of saying what's a good AI from a crappy AI. Crappy AI is when it's really 1,000 people. Yeah.
Right. That's funny. All right. Next question. What have you changed your mind on recently?
That's a great question. That's a fantastic general question. What have I changed my mind on? Wow. I think I used to think that we could I used to think that we could convince people of the benefits of formality. It's how we started, and now I think we're going to have a technical workaround, because I think it's going to be it's probably not just a good path to try to say that the solution is education. So I've changed my mind about where to emphasize kind of the future of societal development around this technology.
What's your wildest AI prediction for the next 12 months?
Well, 12 months is tougher. The next 12 months for AI. I don't know how this is going to necessarily express itself in some sort of Hollywood or telegenic way, but I can say that what's exciting for me in AI for the next 12 months is the degree of improvement that takes place. We as humans, famously bad at predicting exponentials. We had this in COVID, where we couldn't get our hands around how quickly these diseases can spread. Similarly, on the good side, we can't predict the benefits of exponential growth in some of these technologies. So I think it's really it's kind of difficult to express how great some of these technologies will be, in mid 2025. They're going to be fantastically better in some cases, and I have windows into some of that. But man, it blows my mind. It's hard to predict.
All right, final question. What's your number one advice to founders who are starting out today?
Boy, I don't know if I have a number one advice because most people don't want to take advice. So they don't want to hear from me. I've tried this with my nieces and nephews and kids, right? They don't care. Right? They're going to all do their own thing. And maybe that actually is the number one advice. People are looking for advice, and I can often just say that it's guidance, and it can be helpful or unhelpful. But in absence of tenacity, I think being one's own counsel to learn how to make one's own decisions is what I have found serves me well. Because so often the advice I get from other places is well-meaning and contextually accurate, but not contextually appropriate for me. And I have to learn to take that advice and sit with making my own decisions. And maybe this is maybe the piece of advice. I have to get comfortable with people with not everybody agreeing and some people being upset with decisions that are made.
Amazing. Eric, this has been a wonderful episode. Loved your energy. And all these episodes and 140 plus, we've never had a discussion on symbolic AI. So I'm so glad we were able to do this. So thank you so much for coming onto the show and sharing your insights.
I go symbolic AI. Yeah, it's the future. It's good to be here.
Perfect.